this lecture series, we are going to discuss about the ARM processor. So let us discuss what is the basic block diagram of this ARM processor. So we are considering here LH793 ARM processor. That is, we can interface it with the single LED 7 segment, and we have the serial communication protocols like I2C, UART, and USB. And we have ADC, that is analog to digital converter, and matrix format for the desired matrix interfacing. And we have the memory interfacing like EEPROM, STRAM, and NOR. And we have the LCD for interfacing with the display units. And here also we have mic and line in structure for the speaker settings. And we have IDE, that is we can externally connect an developer editor software with it, and we can work on it. And we have Ethernet and MMC and SD card for the memory connections, and JTAG connector. And top we can have the another LCD screen for the display unit. So these are the basic interfacing blocks that can be used along with the ARM processor. Now let us get into the architecture of this ARM processor. So based on the ARM V40 architecture, supporting both the 32-bit and 16-bit thumb instructions. So the thumb instructions reduces the port size and improves the performance in the memory constraint by using the 16-bit instructions, while ARM mode uses the 32-bit instructions. So we have two mode of operations, that is one is ARM mode and one is thumb mode. And in ARM mode it uses the 32-bit, and in the thumb mode it uses the 16-bit. And another uniqueness is it's a non-Neumann architecture with a single 32-bit bus for both instructions and data, unlike the Harvard architecture in the later ARM designs we will be discussing. And so the unique features is one is non-Neumann architecture, that is single bit 32-bit bus for both the instructions and data to be transferred, and it has the two mode of operations. Either it can be used as 16-bit instruction mode, or it can be used as 32-bit ARM mode. And now coming into the performance, clock speeds typically ranges from 20 MHz to 133 MHz depending upon the implementation. So whenever the task is performed, depending upon the task or the application, the clock speed will be utilized. And we have the greatest opportunity here, that is greatest feature here, that is three-stage pipeline. That is, pipeline is nothing but fetch, decode, and execute. In the 8086, we can find a single pipelining technique stands as a uniqueness of that particular processor. And here we have three stage of pipeline for the efficient processing. So three multiple tasks can be performed at the same time. So performance varies based on the specific code variant. That is, it depends upon around 1 MIPS per megahertz. MIPS stands for million instructions per second can be executed per megahertz. So the clock frequency is 20 megahertz to 133. So let us think of within 1 megahertz, we can execute up to 1 million per instructions. 1 million instructions per second, and that too with the clock speed of 1 megahertz. So let's think how efficiency it will be. Next, coming to the instruction set, we have the two instruction set. One is ARM and thumb. So in the mode also we have two types of mode, and in the instruction set also we are writing two different types of instruction set. One for ARM, that is for 32-bit, and one for thumb, that is in a 16-bit. And this includes common instruction sets like arithmetic, logic, branching, and memory operations optimized for the embedded applications. And coming to the memory, yes, it is a 32-bit as we know, and we have access of 4 GB of memory. And typically, as we seen in the block diagram, we can have flash and SRAM, which can be used as external memories if we needed in embedded applications. And no on-chip cache is almost in design. So in everything, every processor or controller, the one major problem is the full memory cannot be utilized. And here we can see there is no on-chip cache is almost utilized here. And second major feature or significance here is low power consumption, designed for the power efficiencies, making it deal for the battery power devices like early mobile phones, PDAs, and portable electronics, that it's purely low consumption. And variants, as we have a few variants from the ARM family, and first one is ARM 7 TDME, and it supports the thumb, debug, multiplayer, ICE, that is in-circuit emulation support. And next one is ARM7 EJS, and this is the enhancement. Later variant is enhancement for the JSLR technology, that is Java acceleration. So here we can implement the Java, and the variants differ in most of the features like debug support, multiplier units, and synthesis capabilities. And interrupts and peripherals, yes, we have a simple interrupt handling mechanism with the two interrupt levels. One is normal interrupt and one is fast interrupt. And apart from that, it can be used with the other peripherals like UART, SPI, and I2C, and timers in system on chip SoC designs. So these are the basic features and details about the ARM architectures. In the next lecture series, we will discuss this mode of operations in detail. Thank you.